Welcome to May at Empirical's SDA Learning Center. In the last video, I demonstrated two different methods of approaching the conversion of AutoCAD drawings into AutoCAD Electrical designs. In this video, I want to continue that AutoCAD Electrical conversion discussion with the use of a tool in the SDS Toolkit. In some cases, the best approach to converting some AutoCAD drawings is to create a hybrid AutoCAD Electrical drawing. A hybrid drawing is defined by me as an AutoCAD Electrical drawing that is designed to be both a schematic diagram and a wiring diagram. This video will follow option 1 from our previous video in April. If you haven't viewed it, option 1 is a conversion method designed to maximize the current look and feel of a client's current AutoCAD standards when converting to AutoCAD Electrical. I'll demonstrate an approach to creating hybrid schematic wiring diagram drawings in AutoCAD Electrical by highlighting the use of the SDS Tielink command. Tielinks are generic blocks that can be used to connect AutoCAD Electrical intelligence into unintelligent raster drawings as well as unintelligent AutoCAD drawings. This is a simple client template drawing of a station service AC panel. Instead of creating multiple instances of a typical circuit breaker like you see here, you may decide to use tie links on one-off template drawings like this to reduce unnecessary bloat in your symbol library. This drawing contains cables that need to be accounted for in our cable list, but there are no schematic instances of these components, such as the panel circuit breakers or welding receptacles, in a schematic, so we need to create schematic instances for cables and annotation. The drawing is already seated with both schematic and wiring diagram tie links. Schematic and wiring diagram tie links are subdivided into component style and terminal style tie links. As you might guess, schematic component tie links pair with wiring diagram component tie links, and schematic terminal tie links pair with wiring diagram terminal tie links. This division creates the same schematic to wiring diagram relationship that is traditional with AutoCAD Electrical. This is an example of a wiring diagram component tie link. The schematic component tie links for some of these component tie links, like the transformer, disconnect switch, and main circuit breaker, are located on a separate drawing, CD2. This is another drawing that is simple enough to use tie links on, but you may decide to create these symbols. Looking at a schematic tie link, it has some very basic information: the tag, installation, location attributes, description 1, 2, and 3 attributes, and the term attributes term 01, X term 01 for direction, and term description 01. This is the schematic information that will drive the wiring diagram annotation on CD1. So now that I'm back at CD1, I'm going to start by annotating these wiring diagram type links and drawing my first cable, 5701S. I'll start by moving out the existing AutoCAD cable, and then under the SDS Panel WD tab, I'll select Add Anno, verify my values, and I'll go ahead and just Windows select the wiring diagram tie links. Once the program updates and draws out the annotation, I'll be able to add the cable. So now that the drawing has pulled in the schematic information from CD2, I'll go under the SDS Panel WD tab and select the Cable Fan-In tool, verify my defaults, and I'm going to start at the transformer and draw this cable to the left. Land the cable right about here. And I'll just keep the defaults, since this cable is not going to have any drawing cross-reference information associated with it. I don't have to worry about filling in any of the deref attributes. I'll run the Cable Fan and WD tool again. This time, I'll select Right, select the annotation on the disconnect switch and draw it. Now I turned on my grid snap on these drawings in order to get these cables along the same line. This will allow me to actually keep the current look of the existing cables as much as possible by simply overlapping the two cable bubbles. I'll hide one description, and that cable is documented and accounted for. So next, I'll draw the schematic version of the cable. So I'll take 2907S and move that AutoCAD cable out of the way. This will be a direct component-to-component connection, so it's going to follow the same rule as the wiring diagram cable we just did. Because this CB1 and this welding receptacle appear in no other drawings and neither reference another drawing, this is the optimal time to actually use the SDS schematic style cabling. I'll make the welding receptacle side of 2907S the source side. Windows select the tie links, turn on my grid snap, and draw this cable out. In description 1, I'll go ahead and enter the cable size for all three conductors. That will end up showing up on my cable to from report. Don't need to worry about updating. Now, I didn't add a cable part number to this cable from our catalog, so I'm going to have to go in, highlight the inline signal arrows, and edit them individually. I'd have to edit the signal arrows manually anyway due to the color code order that's in our cable. Catalog would not conform to the color code that's being wired here. I'll clean up the blank wiring annotation there. And then I'll rerun the command. But this time I'll select destination side and draw it to the left. This cable has to be drawn in two parts because of the weird layout of this drawing. So I'll start at CB1 and draw out the black and red conductors first. And again, because I have my grid snap on it, I can overlap these cables. And change the white conductor to a red conductor. So for the white conductor coming off the neutral bus, I'll rerun the SDS sigfan command and draw another destination cable up and through the destination cable that I just drew off of CB1 to create an intersection. I can pick any point there to land it and just land the bubble and hit OK. To join them, I'll use the add corners command under the SDS fan in dropdown. So after I hide this attribute, go up to the SDS schematic tab, and under the fan in, I'll select add fan in corners, select that, and it adds a fillet. And now I can stretch that wire down, delete the bubble, and then just delete that spare bit of wire. And so that cable point to point is drawn. Before I delete anything, I'll actually update the cable to the correct cable size. A little tip: to keep track of which end of this cable is the parent and which is the child, I keep the parent description visible so I know which cable bubble I'm grabbing when I use the edit component command. But ultimately, this exercise was about incorporating AutoCAD Electrical and maintaining as much as possible the current look and feel of the customer's current AutoCAD standards. This demonstration is a good example of that middle ground option that I mentioned in our April session. Tielinks are predominantly used to create intelligence and hand-drawn raster designs, but this video briefly explored how to use Tielinks to quickly create a hybrid AutoCAD Electrical schematic wiring diagram within that AutoCAD drawing. Tielinks offer an incredible amount of creativity with the ability to add data while also being discrete. You may even explore adding them directly to vendor drawings to create data on drawings that you were already including in your design package anyway. The key thing to remember is that Tielinks can be customized to fit almost any application, and they can be customized. You can add the Tielink geometry to a non-plotting layer, like the def points layer, and make them disappear entirely from the package once the drawings are printed. In next month's video, we'll explore some additional SDS Tielink functionality that will help increase the speed of your designs. Thanks for stopping in again. See you in June with more AutoCAD Electrical content here at the Empirical SDA Learning Center.